Okay, let us start today's session with performance killers. I already have discussed the background about these all things. Now, let us see these all things in an action. So, here is the list of performance killers in SQL Server. Whenever you see that performance of your queries are degrading, right, then you have to look into these causes, right? So let us discuss about the first killer or the first cause of performance degradation for queries, that is missing index. So let me put some queries here. Oh, I think Management Studio is not started. So what happens here, meanwhile it is starting, let us discuss about this. This is my complete query, right? And here we are joining multiple tables. You can see here we are joining sales sales order header table. Okay, don't recover. Let it come then. Then we will start to discuss. So here is the query. You can see that we are joining multiple tables here, right? We are joining first of all with sales order header table with sales order detail. Then we are joining that table. This is a key join. We are joining on column here with similar value in both the tables. Then I hope you all know about aliasing, right? So from sales order header as SOH. SOH is the alias, that is given to sales order header table. Likewise, SOD is the alias given to this table. You can write as or you cannot write as. It all depends on you. Then we are joining these two tables. You can see here on a particular column. While I'm talking about this, let me come to that point. So I will discuss about this later on. Likewise, we are joining again these two tables here with this sales order header and sales order detail set with product, right? Then again with cust- uh, customer table of sales schema, right? And person table of person. Many tables we are joining here, but we don't have to worry about this. When we are talking about missing indexes, it means that the column which appears in my predicate, if this does not have an index, or in another word, if we have not created an index on line total column, right, of sales order detail table. This line total column is the part of sales order detail table. So if we don't have a non-clustered or cluster index created on line total column, then what will happen, right? Instead of what I would say, seek, a scan would happen against the cluster index, right? So let us see this in action. First, check that whether we have an index created on line total column or not. If we have, what we will do, we will drop that index and then we will run this query here. So let us try to expand sales order detail table and check for indexes, what indexes we have. So as per the nomenclature, it seems that we have an index on the line total column. So let us do one thing. Let us script this out and drop this index. So I'm going to drop this index here. I scripted it out. You can see it is created on line total column here, right? Now what I'm going to do, you can see I have many indexes created on different columns. This is created as a non-clustered index on sales order detail, followed by product ID column. It's a composite index. Then this is created again a non-clustered index. It is created on sales order ID column. This is created a clustered index. This is created on sales order detail ID column. This is created on modified date. It's a non-clustered index. And this is created, this is again a composite index created on two columns, sales order detail and rows GUID. It's a non-clustered index. So out of these all indexes, what we see that we don't have any index on line total column, right? So rule of thumb, please note these points carefully for the best performance of your queries as you are learning performance tuning. The rule of thumb is that the column which appears in your condition or in your predicate in relational algebra, this condition is known as predicate. So in interviews, you may be asked the question, what is a predicate? Right? Especially if you are being interviewed in a good company like Microsoft or TCS, Accenture, they can ask you the question that what do you mean by a predicate? So although you are using predicate in your queries, but many people know that this is a condition, but in relational algebra term, it is known as predicate, right? So rule of thumb is that the column which appears in your predicate must have at least one non-cluster index created in advance. Sorry. So in this scenario, we must have a non-cluster index created on line total column that we don't have. Deliberately, we deleted that to discuss about missing indexes. This is the first rule of thumb. Second rule of thumb for good performance of your query is that on whatever columns you are joining the tables. For example, let us take this example. Here we are performing an inner join, right, on columns. Sales order ID column of the sales order header table and sales order ID column of the sales order detail table. So we must have uh, non-clustered indexes created on these two columns in these two different tables for the best performance of my query. If you don't have, in that case, you will see that an additional sort operator will be introduced in your query plan. I will show you, not right now, later on. Likewise, you must have a non-clustered index created on the product ID column of the sales order detail table and product ID column of the person table. Likewise, you must have an index created on the customer ID column of the sales order header table and customer ID column of the customer table. And same thing is here. You must have an index created on the person ID column of customer table and business entity ID column of the person table. This is the second rule of thumb, right? So if you have more rule of thumbs are there, we will talk about those later on. But right now from this query, we point out two rule of thumb that must be followed for the good performance of your queries, right? So whatever we have discussed, we can find that in our plan. And for that, let us execute this query by selecting the actual execution plan. So whatever plan it will generate, and using that plan, this query will be executed. That will form the actual execution plan. And there we will see about the missing indexes detail that will be displayed by your query plan. So I treat query plan as a tool. That is what I told you yesterday also. Let us execute it and see this in action now. It returned me 3 rows. And if I come to execution plan here, obviously you see here missing index. impact is 78.89, means 79% impact is there. What does it mean? That whatever my query plan is suggesting me to create an unclustered index, if I create that, my query performance will be improved by 78% of time. So for that, what I am going to do, before creating this index, let us capture um, two statistics. The first is IO statistics. So set statistics IO on, and set statistics time on. I'm going to capture these two statistics, right? Now, oh, mouse is not working. Just a minute. Now let us execute this query again. We have not created the index yet, but we will have messages as well. So same thing here. You see that my query plan is suggesting me to create a missing index, which can improve the performance of this query by 79% of time. And what it is suggesting to create, for that you have to right click on this, and you have to create on missing index details. So in the missing index details, you will see that query plan is suggesting to create an index on line total column of the sales order detail table. And at the same time, it is suggesting me to include these two columns also, right? So why it is suggesting me to include sales order ID and product ID column as well? Let us try to discuss about that. So it is suggesting me to include those two columns also because they are part of my projection. So what columns it is suggesting? Sales order ID and product ID. Obviously, we might be either, accessing it, or what columns it is suggesting? Sales order ID and product ID. Okay. So first name, last name, name, product number, order, line total, total due. Okay, so it's not there. It means that these columns are appearing in my EQ joins, sales order ID and product ID. Let us see that, whether they are appearing here or not. In this, it is not there, but here you can see that product ID is appeared in EQ join here for the sales order detail table, and one more column it is suggesting, that is sales order ID. So let us see where sales order ID is coming. Here it is sales order detail, sales order ID, right? So that's why it is suggesting me to include those columns as well. Now, before I create this non-cluster index, let us do one thing. Let us come to the message and capture its IO statistics and time statistics. So from here we can copy it. This is my IO statistics and time statistics. Let us just put it below. We have captured it. Now, whatever index it is suggesting, let us create that. So whenever you are creating a missing index, just give the name as missing IDX, then the column on which you are creating it. I am creating it on line total column. So specify it and include those columns also, specify those columns also, which you are including in this. So we are including these columns here. Oh, sorry, Control Z, Control C, and here Control V. Now, my definition is ready. Create non-cluster index, missing index. This is the name of my missing index that I'm giving. And we are creating it on line total column. And additionally, as per the suggestion by query plan, we are including these two columns also. So let us go ahead and create it. We created it now. Now come to your query and let's execute it again and capture the IO statistics and time statistics for this query. Incorrect syntax. Oh, sorry. We have to select only this part and execute it, right? Well, it is executed. Now in the execution plan, you can see that there is no missing indexes suggested by the query plan. So we are fine here. And if you come to message, you have the IO statistics and time statistics here. So let us compare this without copying. So come down, and here we can compare against the product table. Here 6 logical reads, it is same. 6 logical reads against person table, 12 logical reads are now here. And against customer table, 9 logical reads are here. It is increasing. But against sales order detail table, earlier there was one scan count and logical reads were 1259. So here you can see against sales order detail table, my scan count is still 1, but logical reads have been reduced from 1259 to 3, right? So you might be interested to know about physical reads and logical reads. Physical reads refers to those reads uh, for which data pages are read from disk and loaded into SQL buffer. Logical reads are those reads for the data pages which are available in SQL buffer and they are read from the SQL buffer itself, right? So you can see that logical reads 1259 has been reduced after creating the missing index from 1259 to 3. It's a big improvement, we can say. So obviously, we must have reduction in query execution time as well. So let us compare that. Here you can see earlier the actual execution time. This is the code execution time of the query. That was 156 ms. Now it is almost 0 ms. 0 ms means 5 or 10 ms, 10 ms milliseconds it might have taken. But overall, the elapsed time has reduced a lot from 242 ms to 72 ms, right? So this is a big improvement in query. Hence, the logical reads have been reduced. Once you are able to reduce the scan count, logical reads, and physical reads, certainly your query will be execute faster, right? So my query now executes faster than earlier one, right? Any question here? No question.
No, sir.
Shonet has also joined. Hi, Shonet.
Sir, yes, sir. Sir, one question, sir. Sir, can we blindly believe on the query plan, like whatever it is suggest?
See, the rule of thumb is that whenever you are working on performance part, right? So even if your query is plan is suggesting to create missing indexes, you should not do that, right? You should do only when that query is not being executed as per the expected time. So, for example, see just this query. This query gives me some kind of report, and here is your report. It gives me the name of the salesperson, right? Followed by its address, followed by the product number, order date, and how much business it has generated, right? And total due amount. So it gives me some kind of report. So if it gives me a report within, say, 30 seconds, and my end customer is happy, although my query plan is suggesting me to create an execution plan, create a missing index, I will not go to create the missing index. But if it is it is required that this query should execute in order to fetch this report in 10 seconds, right? And it is taking suppose 30 seconds. So in that case, obviously I will go ahead and create missing index. So unnecessary, you should not create until and unless a performance degradation has been reported to you, right?
Yes, sir. Okay. Thank you, sir.
Okay. So this is all about missing indexes. You should create that in that case. The next performance killer is your stale statistics. I have already explained about statistics in detail. Perhaps you all people have attended that session. Those who have not attended, right, please go through the recording, right? You will have a very
Sir,
fair
voice is
idea
breaking,
of
sir.
can tell me how SSL. My voice is breaking. Yeah, it seems my internet connection is unstable. My Wi-Fi is not working today. Okay, let me connect. It has come. Let me connect to my How is the sound now?
Sir, much
Yeah, it's
better.
okay, sir.
Should be better, right?
Again, the problem is,
Still, it is breaking.
yeah, sometimes it's breaking, sir.
It will. I hope it will not break because we
Yeah,
just have a
right now, not.
yeah, we just established the connection, so it takes a few seconds. So now it should not break. Uh, I asked one question. Oh, let me check with the recording. Yes, it's going on. So my question is, can you tell me what statistics is and what data it contains? What are the different kinds of statistics you have and how it helps optimizer, while while optimizer is creating the plan. Can anybody tell me? I already have explained it. No idea? Okay, so let me answer the first question.
No,
Statistics is a database level object, the first thing, right? On database level, you have many objects such as tables, views, indexes, triggers, stored procedures, functions, synonyms. You have many objects on database level. Likewise, statistics is a database level object. There are two kinds of statistics. The first is index level statistics, and second is column level statistics. So let us expand statistics here. And you see here whatever indexes you have, 1, 2, 3, 4, 5. Let us refresh it. You should have 6 indexes. One was based on line total column that we created. Yes, 1, 2, 3, 4, 5, 6. So now these 6 statistics are also here with the same name. Let us refresh it, and you should have 6 indexes: 1, 2, 3, 4, 5, and 6 with the same name. So the moment you create an index, your statistics is created, and that is due to the setting on database level, which is auto create statistics, that is set to true. And it is recommended that it must be set to true. I'm talking about this option, auto create statistics. It must be set to true. Otherwise, what will happen? Whenever you will create an index, statistics will be not created automatically or by default. So it's a poor practice or bad practice to disable this option by setting to false. You must set auto create statistics to true in order to have a statistics created automatically. Clear? Second type of statistics you see, which starts with underscore WA underscore sys, followed by some unique numbers, and then followed by some hexadecimal numbers. So every statistics here you see that it starts with underscore WA have a unique number. These are known as column level statistics. So whenever optimizer thinks that the predicate that you have specified requires requires its statistics information, right, in order to estimate the number of rows on which a particular operator has to operate. I'm going to explain that. So for that, it creates column level optimizer creates column level statistics on the fly when you execute the query. So at the runtime or on the fly, it creates column level statistics. So there are two kinds of statistics. Now, how statistics help optimizer? That is the next question. So let me show you one thing here in the execution plan. You can pick up any of the operator. Let us go to the right. We read the execution plan from right to left. So just try to see any of the index that we have created. We created a non-clustered missing index here. So let us hover over the mouse here on this operator and see estimated number of rows to be read in the first section. This entire tooltip is divided into 4 sections. So in the first section, from the bottom, it should be fifth line, 1, 2, 3, 4, 5, fifth and sixth line. It says that estimated number of rows to be read is 66 point something, estimated number of rows. And if you go to actual number of rows, it says 3, right? So your statistics helps optimizer in deciding in estimating that how many number have to be have to be reads in order to perform a particular operation. So here index seek is a particular operation, and for this index seek, how many rows have to be read? That is what it is saying here, 66.79, right? So let me explain it very simply. And for that, what I'm going to do, I'm going to write a query, select a star from, say, for example, sales order detail. Why mouse is not working? Uh, Let us execute this and we will pick some value for sales order ID, where sales order ID equals to particular value, right? Let us see its plan now. So execute this query and capture the plan, include actual plan. Let us capture its plan. So here is the execution plan, and what operators it has used. It has used many operators. It has used index seek, and then it has used key lookup, right? So let us come to the first operator, that is index seek. Second operator, this first operator it is, right? So index seek is here, and it is happening against a non-clustered index, and that is IDX sales order ID, right? Under the object section, you can see the index that is being used is IDX sales order ID, right? So it has returned me, it is saying that estimated number of rows to be read is 12 in the first section from the bottom, that is the fifth and sixth line. And from the top in the first section, fifth and sixth line is number of rows read and actual number of rows, that is 12. So both are same. So from where this information optimizer has got, this information has been obtained by optimizer from the statistics. How we can see that? So for that, you have a dbcc command, dbcc so statistics. This is correct. And first you have to specify your table name. So my table name is here, sales order detail. And then you have to specify the index name, which index it is using. It is using IDX sales order ID. So it is here, or statistics you have to specify. So it's IDX sales order ID. Let us copy it from here. So I'm specifying it here, and let us get this information. So what is the query you have written? Select star from sales order detail, where sales order ID equals to 43659. Now, with the help of dbcc so statistics command, we have the output of this statistics, which is divided into three sections. The first section is somewhat informative. Second also gives you some statistical information. And the third section is known as histogram. So if anybody asks you what statistics contains, so you can say that statistics contains a histogram in which it stores the information about the data uh, for its distribution range, right? We know that in this table, in sales order detail table, we have more than 1,20,1,000 or 23,000 rows. 1,21,317 rows are there. So if you come here, you will see that in statistics, 1,21,317 rows are stored as steps. So these are stored as 153 steps, right? Now the statistics contains information only of the column values on which the index has been created. So IDX sales order ID, if I expand this, if I script out this index here, you will see that it is created on sales order, on what it is created. No, I picked the wrong one. This one is there, right? Sales order ID. So you see here that index is created on sales order ID column. Now you see that in the sales order ID column, what values we have. This is the sales order ID column. It says starts from 43659 and goes up to 75123. So if you come to the statistics, right, the first section that you see range HI key, which is distribution range of the column value on which the index was created, that is sales order ID. So it just starts with 43659. Next value should be 4365659 Rather, it is storing 43692 because it does not store information about all the rows. 1,21,317 rows. Rather, it store all values in 153 steps only. These are the steps that you have. 153 steps you have. You come here. So the last value you see here is the highest value, that is 75123. And the lowest value from where we started was 43659. Now, something you have to understand here, that equivalent to this 43659, there are 12 rows, right? What is the condition we have written here? Sales order ID equals to 43659. It means that equivalent to 43659, we have 12 rows in this table. And that is what exactly appears in the execution plan. Let us execute this. So if you hover over the mouse here, you see here, estimated number of rows to be read in the first section is 12. So this information is being obtained by the optimizer from the statistics. Got it? That is how statistics helps optimizer in deciding uh, the number of rows to be read in order to perform a particular operation by a particular operator. So here index seek is my physical operator in this plan, and the operation is seek here against the non-cluster index, right? For how many rows it has to perform the seek? Only for 12 rows, right? So this information it is getting from the statistics, right? You see here. Let us try to change this condition, and let us try to make this condition somewhat different, where sales order ID, and I am going to write here sales order ID between this value and this value, right? So now again, it will do some estimation. So before I show you the estimation that will be done by the optimizer with the help of statistics, let us calculate it manually here. So the predicate or condition is where sales order ID between 43659 and 43692. So equivalent to 43659, I have 12 rows in the table. Equivalent to 43692, I have 28 rows. So 12 and 28, 40. And in between 43659 and 43692, which is captured under range rows, is 282. So I have a total of 282 plus 40, 282 plus 28 plus 12. That is 282 plus 40. I have 322 rows. So this query will return me 322 rows, and that information you can also see in the execution plan also. So in the message, you see it has returned me 322 rows. Here is the result set that contains 322 rows. You can see here, right? And if you come to execution plan, here now on the index C, IDX cells or ID column index is being used. And under the estimated number of rows to be read in the first section, you see here 322 rows. And on the top of the first section from the fifth or sixth line, you see their actual number of rows is 322. Number of rows read is 322. So this information is obtained by your optimizer while it is generating the plan from the statistics, right? So now you should have fair idea about statistics, what your statistics is. So your statistics is a database object. There are two kinds of statistics. One is index level statistics, another is column level statistics. Index level statistics are created at the moment when you create an index. Column level statistics are created on the fly. If your predicate is missing have a missing index, in that case optimizer creates a column level statistics on the fly in order to have its own estimation. Then what statistics contains? So statistics contains basically a data structure that is known as histogram, in which it stores the information of the column value on which index was created. In this case, the index was created on sales order ID column. So it contains the information of sales order ID column, and it contains the distribution range of values, not all rows. This is the distribution range of values, right? And this distribution range, this is structure in which it contains the distribution range of column values is known as histogram. And this histogram helps optimizer to estimate the number of rows in which a particular operator has to operate. So in this case, index seek is my operator. This is a physical operator that appears in the graphical execution plan. And the operation that it is performing is a seek operation against the non-clustered index, right? And for that, the estimation of rows to be read is done by optimizer with the help of statistics that is shown here as 322. You all should be clear now about the statistics. So if your statistics is not updated, the estimation of number of rows to be read by a particular operator in order to perform a particular operation will be wrong, then your query will execute slowly. So when it will be wrong? When your statistics will be outdated. Outdated statistics are also known as stale statistics. So here you can get the information, what is the name of statistics, when it was lastly updated, right? So it was lastly updated on 16th April. How many rows it contains? This contains this many of rows. Then how many rows have been sampled? It's a good thing. Whatever rows you have in your table, if all rows are sampled for creating a statistic, it's a good sign. And then how many steps are there for storing the distribution range of column values, right? So that is 153 that you can see here, 153, right? 153. is the distribution range. Uh, then I'm not talking about the density right now. So after that, the final structure is your histogram, and that usually helps your optimizer in order to perform the estimation of number of rows to be reached by a particular operator in order to perform a particular operation. So this is all about the statistics. That's why your statistics must be updated. If it is not updated, if it is stale, then the estimation that your optimizer will do in order to perform a particular operation, right, that will be wrong. The estimation for the number of rows to be reached to perform a particular operation will be incorrect. And when the estimation of number of rows to be read is incorrect, that will finally resulted in poor execution of the query. So your query performance will be slow. In that case, that's why stale statistics is considered as one of the major performance killer in SQL Server, or outdated statistics is considered as one of the major performance killers in SQL Server. All are clear? Any question here? You all are there?
Yes, sir.
Okay. So should I go for the next one? Okay. Next performance killer is next performance killer is implicit conversion, right? So let me explain it through one of the example. There are two kinds of conversion that you can do in SQL Server, right? One is explicit conversion and another is implicit conversion, right? So what does that mean, implicit and explicit conversion? Let me explain you. So for explicit conversion, what I can do, I can introduce either convert or cast function before a column value or any value, right? That is known as, if when you convert a particular value by using cast or convert function, that is known as explicit conversion. You are doing that. But sometimes what happens, developers write the code and internally implicit conversion occurs, and that badly impacts the performance of your query. And that is exactly what happening here. Why it is happening? Let me explain that. Here is the account number column, and this account number column is the part of your customer table. So let me check for that table here first. Sales.customer is here, right? Let us expand this column name here. Uh, Account number column, right? Account number column is here, and it's a computed value. It's showing, and it's of varchar type, right? You can see it's varchar type, right? It's varchar type. You see here, account number column is a varchar type. We are in this condition or in this predicate, we are comparing values which are stored as varchar type in the account number column with a literal or literal string which is of nchar, right? Try to understand this. Every varchar or simply char type of column stores each character in a single byte. You are getting me what I'm explaining?
Yes, sir.
Every varchar or char type of column stores your every any, not to use the term every, any varchar or char type of column stores each byte as in each of the character as a single byte, whereas any in char or in var column stores every character as 2 bytes. So both are different data types in nature. So far, they are concerned in the storing mechanism of the data. These two have different mechanisms, right? Now, what is happening here? My account number column is of varchar type, and I am comparing it with a nchar literal, right? Some people also say it's as a constant. Some people say as a string, but the adject term is literal. And if you want to make it more easy, you can say literal string, right? So what is happening here? This is my account number column, which stores my data in varchar type, right?
Sir, we lost you. Sir, we can hear you, sir.
Hello, am I audible?
Yes, sir. Now you are.
Yeah, so we lost for some time. Recording is going on, not a problem. What I was talking there. You see here that we have 19,820 rows in this customer table, right? So in order to uh, compare these values for 19,820 rows, it means that we have 19,820 account number column values, right? You can see. So these all have to be converted into nchar first, then only this comparison will take place, right? It means that all rows of this table has to be read for converting the account number column values. And whenever all rows have to be read from a table, optimizer has the best access method for reading all rows from the table is index scan. So ultimately, this implicit conversion that is happening here, where the account number column values which are of varchar type have to be converted into nchar. So for that, a index scan is required. Although I have an index created on the account number column, let me check whether we have any index created on account number column or not. I am sure we should have. Yes, we have a an index created on account number column. So in this case, what will happen? Although I have an index created on the account number column, right? So although my first criteria for performance tuning is fulfilled, that I have an index created on the column in my predicate or in my condition, but index seek will not take place here due to implicit conversion, because each of the values which are stored in the account number column as the varchar string, they will have to first convert it into nvarchar, and then only this comparison will take place. And in order to convert these all values in the account number column, right, these values have to be read first, and in order to read these all values, index scan will take place. So what is happening here, the implicit conversion is not allowing index seek to occur, rather it is forcing index scan to occur. So this implicit conversion always forces optimizer to perform an index scan instead of index seek, even if I have an index created on the column which appears in my predicate. So let us see this in action here, right? And capture the statistics as well. And let me close these all first. So let us close this window. Let us close this also. Let us close this also. Let us come here and copy these two and then close it. Let us put it here. So let us see this complete in action, and at the same time capture the execution plan as well. So include actual execution plan, execute it. And if you come to execution plan, so if you go there, you will see that against the what is this non-cluster index is there, but a key lookup is happening against my cluster index here. And then so anyway, the index that is created on account number column, right, with this name AK customer account number, is not being used at all. You can see here this refers to a non-clustered index against a index scan against a non-clustered index, and then a key lookup is happening against the clustered index. Then a clustered index seek is happening against a different person table, right? Nothing is happening against my this index AK customer account number. Usually it should happen against the account number column, right? So that is the first thing. Second thing is that if you come to the leftmost part of the execution plan and hover over the mouse on the first operator, you see the warning. It's a yellow triangle sign. That is the warning sign you see here. And if you hover over the mouse at the last section, you see warning. Type conversion in expression convert implicit. Here implicit conversion is happening in varchar 10 comma C account number. See here. So varchar is being converted into nvarchar in order to compare that literal nchar literal AW 000299594, right? And it says that may affect seek plan in query plan choice. It is affecting that. So we have, whenever you see a triangle sign, it's a warning, and it's warning here. You, if you come to the warning section, you can understand that. So here it is type conversion. That is what exactly we were talking. So it's implicit conversion that is going on, right? So what is the solution here? The solution is, okay, now the next thing what we are going to do, we are going to capture these two information here, right? So let us capture this. Right now, 3 logical reads are happening against person table, 1 scan count, and 39 logical reads are happening against customer table. And the query took a total of 156 milliseconds for the execution. That is the code execution time, and the total elapsed time that includes the parse and compile time as well is 266 ms. Now what I'm going to do, if we simply just exclude this n. So now this account number column is of varchar type, and the literal is now char type. Varchar and char both are compatible to each other, right? Because in varchar also every character is stored as 1 byte. Every character is stored in 1 byte, and in char also, right? In char type also, every character is stored as 1 byte. So these two are compatible with each other. Now, if I execute this query and capture the execution plan and IO and time statistics, right? So you will see now in the execution plan that this index will be used with the seek operation. Let us execute it. Come to the execution plan now and see here. AK customer account number index is being used. If you come to the object section, the second section of this tooltip, AK customer account number of the customer table is being used here, and against this non-clustered index, seek is being performed, right? So it's a good sign here, right? And there is no warning sign now, so no implicit conversion is happening. This is a good sign that seek is happening here now. And if you come to the message, you will certainly see reduction in IO statistics and time statistics. So here you see that logical reads from the customer table has been reduced from 39 to 4, and a scan count has been reduced even from 1 to 0. It's a good sign, and consequently we have increased execution time here. Almost it's 0 millisecond, means 5 to 10 or 12 or 15 milliseconds, right? Earlier it was 156 milliseconds, right? So this is all about implicit conversion, right? But sometimes you have to do explicit conversion by using cast or convert function. There is no way to go out from that situation. So in that situation you have to do, so you have to do, right? Any question here? You all are clear? Okay guys, so I'm just stopping the recording, and I will be back in 5 minutes, and then we will talk about non-chargeable predicate. This is the question that is most frequently asked in interviews. What do you mean by chargeability? What is a chargeable predicate? And when a predicate becomes non-chargeable, such questions are asked. So let us have a break of 5 minutes, and after that I will explain these all things. Recording here. So let us talk about the next performance killer, that is non-chargeable predicate. So now we all understand what a predicate is. what a chargeable predicate that we have to understand first, and what the charge means here. You can see it is written in caps. So charge stands for search. Uh, that this complete word chargeable stands for search argumentable, right? Where it states that uh, the predicate that you have written, if it qualifies for an index seek operation, so in that case, it's a chargeable predicate. Let us try to understand this with this example here. Likewise, if we show in this case, uh, here we have an index created on account number column. This is the index we have, right? And we are doing a equality search here. So whether it is equality or non-equality search, that doesn't matter. We are doing a comparison here, right? And if it qualifies for seek, right, then it's a chargeable condition. It's a chargeable predicate. So if you see the execution plan that we executed earlier, that it is qualifying for a seek, index seek against this non-clustered index, right? Got it? So it's simply a chargeable condition. Now let us try to understand more here. So whenever you write a predicate or a condition, you write in if you write that in this manner, where you write where and some function, say for example, you are converting some column values in the left hand side of the predicate. This is your complete predicate, right? So here you write the column and you are introducing, say for example, some cast convert function, or you are converting into int integer or car, something like that you are doing, or you are just using the substring function, something like that. If you are using, if any kind of function you are using in the left hand side of the of your predicate. So usually in the left hand side of your predicate is your column. So anyway, if you are using any function against your column in your predicate, right, then your predicate or condition becomes non-chargeable. But if you use any function in the in the right hand side of your predicate, right, in the right hand side of your predicate, that condition is chargeable. So let me show you through some relevant example here. Here is the example. You can see here, this is my predicate, right? And I am using a convert function in the left hand side of this predicate. This convert function is finally being applied on the modified date column of the sales order detail table, right? So this is a non-chargeable predicate or non-chargeable condition, right? But if I convert this data string by using the convert function into a particular date format, right? And then we are comparing that with modified date value. In that case, it will be considered as chargeable predicate. So let me put both queries here, which are example of chargeable and non-chargeable. Then you can understand it better. So this is my first query. And in this query, this is my predicate. In the left hand side of the predicate, here we are doing the conversion on modified date column. So it's a non-sargeable predicate. In the second query, which is returning me the same result, we are not doing any conversion here. Modified date greater than or equals to this date value, or modified date less than this value, right? We are not doing any kind of conversion either in the left hand side of the predicate from the equals to, this is the left hand side and this complete is the right hand side, right? So we are not doing any conversion either in the left hand side or the right hand side of this predicate, right? So it's a sargeable condition, I would say. Whenever your condition is non-sargeable or your predicate is non-sargeable, it always resulted into a scan, index scan, right? Although you have an index created on the modified date column, but finally it will resulted into index scan because all the modified date column value will have to be converted into this given format 101 format, right, in the varchar type, uh, which is done by the convert function. So for that, again, each value for each row of the modified date column value have to be reached, and the only for all the rows, and the only best access method to read all values from the table that we have is index scan or table scan. In this case, we have index created on modified date column. Let us see that we must have. So sales order detail, and let us expand indexes. We should have here, you see here, modified date column. So although we have a non-cluster index created on modified date column, but hence this modified date value have to be converted into varchar in this date format 101 format. So a index scan is required, and here hence index scan will come in picture. Even though I have a non-clustered index on modified date column value, my predicate becomes non-sargeable. In this case, we are not doing any conversion either on the left hand side of the predicate or on the right hand side of the predicate. No conversion is going on, right? So you will see that here against this index, you will see index scan will come in picture in the plan, and here you will see index seek will come in picture. Let us capture the plan of both the queries by executing it simultaneously, and I will tell you more things here. So come to the execution plan directly, and here you see one warning sign, and this time it says type conversion expression warning, convert this may affect coordinate estimate in query plan choice, expression convert this, right, may affect seek plan. So it is specifying a wording here, giving me a warning. Right now, if you come to the plan and check the index operation that is going against this modified date index, idx modified date, where is that? Cluster index, pk sales order date. So that is not being used at all, right? That is not being used at all. That index is not being used at all in the first case. In order to convert this modified uh, date date values into varchar in 101 format, rather you see that uh, a index scan is happening against this, where it is, object against this cells order detail ID, which is my cluster index, right? So cluster index contains all column values, and hence it is being scanned in order to modify the modified date value into varchar, right? Now, if you come to the second plan, you will see something more interesting. I'm sure that index seek must be happening against this modified IDX modified date, uh, you know, uh, non-cluster index. So that is here, right? You see here, index seek is happening against. If you come to the object section, you see that IDX modified date, right? So in this case, index seek is happening. That's why my predicate is searchable in the second case. And in the first case, my predicate is not searchable, non-searchable. Now, if you want to compare the performance, so then you see there that the first is the relative cost of the first query is 47%, where the relative cost of second query is 53%. So as per the execution plan, my first query executes better than the second one, but again, it's not good. So we have to check for the IO statistics and time statistics as well, right? But I'm not going in the direction right now. So my objective was to only show you about the searchable condition and non-searchable condition. So I hope now you understand that. Any question here? Okay, guys. So you are 1, 2, 3, 4 here only. Okay, so I will send this document to all of you. Perhaps I sent it yesterday as well. Did I send the document to
Yes, sir.
this document? I already have sent, right? So your task is to learn about the remaining things, right? For example, you have to learn about bad parameter sniffing or whatever I have mentioned here. Implicit bad parameter sniffing. It's a big topic. It will take at least 40 to 30 minutes or an hour to complete. Then what are the things you have here? Parameterized query, optimized for ad hoc workloads. A lot of things are there. It's a big topic, right? Inappropriate parallelism is the sixth one. So we will talk about these things, right, in the or in next class. Okay. So we are wrapping up session today here, and I will send you recording to all of you, and we will talk more in the next class. And next class, I will try to schedule from 8 p.m. So that we can have longer sessions. Okay. 7 p.m. or 8 p.m. I will try to schedule that class. It's all right,
Okay.
guys.
Yes, sir.
Sir, 8 p.m. is fine, sir.
Okay. Okay, guys, then we will see you.
Thank you, sir.
Thank you. Have a nice
Thank
night,
you.
sir.
Yeah.
Good night, sir.
Good night. Good night.